Today we're doing understanding linear measures. We're going to start on this side and then fold it over like this. And you want to make it go a little bit over the dotted line this time so it'll fit correctly. We have talked a little bit about line segments. A segment with two endpoints is considered a line segment, so these two endpoints. We also talked about how to name it. It is named segment AB, or we could call it segment BA. So the order doesn't really change which segment we're talking about. The measure of the segment is just the capital AB, but we don't need the notation of the segment because we're actually talking about its value. It's written as which includes a unit of measure like an inch or a centimeter. We're going to look at that in the other side of this sheet. Congruent segments, what that means is just that the picture is the same. We talked about that last time, that when you use the symbol, you're talking about its picture. But thanks to the congruence theorem, we also know that they will have the same measurement. The same measure. Calculating measures. The whole is the sum of its parts. What does that mean? That means that if you have this piece right here and this piece right here, you can get the total piece AC. You just add them together and they'll equal the whole. Point B is between point A, B, and C. So between, remember, is different than midpoint. It's just somewhere in the middle. It could be somewhere in between. It could be closer to the A or closer to the C, and it would still be considered between. If and only if A, B, and C are collinear. Then we're going to open it up. It says calculate the measure of each segment in inches and in centimeters. So we're going to use the ruler this time. If you have a ruler at home, that's great. In case you don't, just watch and see how it is that we measure. Let's first start with inches. And in your ruler, it should say inch, and it should have a 0. You want that first line to be somewhere in the middle of the first endpoint. And you kind of line it up so they're parallel lines. And I'm going to zoom in a little bit. And you just count how many of these little bars there are between. There are 16 from 0 to 1. So there's 16 of those little bars from 1 to 2. Let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 1 and 13/16. Again, why we have that measure is because we had to go all the way to the 1 and then count 13 of those bars out of 16. If your fraction can reduce, then we reduce the fraction. For centimeters, we flip the ruler over. How we can tell that we're in centimeters is because it says centimeters right there, and then the numbers are all closer together. We try to put that first mark right in the middle of the first end point, and then try to make it as parallel as possible to the other point. And we count. We're already at 4. So 4, 5, 6, 4. 1, 2, 3, 4, 5, 6. Maybe 7. Let's go ahead and go with the 7. That is the one closer to the middle of that end point. So we have 4.7. Why is this one in decimal and this one in fraction? We can write this one in fraction if we wanted to, but saying the decimal for 13/16 is not easy. How did we get this 0.7? Well, there are 10 little marks between each centimeter. So if we go to 7, it would be 7/10, which is the 0.7. If you can reduce a fraction, you always try to do so. All the others are pretty much the same for the purpose of saving a little time. And that's what we're going to do. If you would like to review on how to measure segments, just go backwards on the video to see it again. Let's move down. Find the measure of each segment. And it wants the segment AC. So it wants this plus this. And that's exactly what we're going to do. 4.3 plus 3.1 is equal to the measurement of AC, which gives you 7.4. Since it says centimeters, then we're going to write centimeters to give me the final answer. On BC, what you have is the total. So from the total, if I take this away, it's going to tell me how much I have left for BC. The total. Take away this part that we have, gives you what's left on BC. So we're going to write 9 minus 5 3/16. There's a lot of ways that we could do this. We could do it in the calculator. We can change the fraction into improper fractions. What I'm going to do is make two different fractions. I'm going to have 8 and 16/16. Because 8 and 16/16 is one more, making it 9. Minus 5, and then 3/16. What I'm going to do is subtract whole number with whole number. So that's 8 minus 5, giving me 3. And then fraction with fraction. So 16 minus 3, which gives me 13. 16ths. Gives your answer in fraction form. The way that it's asked is usually the way that we have the answer, and that is the answer for BC. And it wanted it in inches, so we're going to write inches. If they gave you the value in decimals, then we try to answer the question in decimals and with the correct units. This problem is the problem that will most likely be in your test, a problem that looks like this one. What do we have? We have this picture right here that tells me A, and then B, and C. I'm going to try to be more specific, but these points have to be collinear like it was mentioned in the front part of this foldable. That means that this is 4x, and this is x plus 5. All together, that equals 35. Then our equation is 4x plus x plus 5 is, we combine like terms. That means this plus this. There's 4x's here and 1x here to making 5x. Plus 5 is equal to 35. And I just brought the rest of it down. We're going to have to subtract 5 from both sides. 5x is equal to 30. This is multiplication, so we have to use division, divided by 5. Making our final answer, and I tend to go like this when I don't have enough space. X is equal to 6. Since it asks for the value of x, that is your final answer. I'm going to make a box right here telling me that that's my final answer. But I want to make a little note over here that what happens if I ask you for AB? AB is equal to 4x. Well, we know the value of x, so that's 4 times 6, because we know that that's multiplication, making the value of AB 24. If I ask for AB, make sure that you answer the question and plug in the x to get the value of AB. these problems right here. It says determine any congruent segment. The picture actually tells us which segments are congruent. Once the marking is the same, they're telling us that the segments are congruent. That means that AB, the segment AB, is congruent to the segment BC. And the segment AE is congruent to the segment CD. Because the markings are the same. Please be careful. It does not mean that BC is equal to CD. Those markings are not the same and would not be congruent. The next one. We have 3 different measures. That means that none of them are congruent. Please answer the question and write no sides are congruent. Because if you leave it blank, I might think that you just forgot to answer the question or don't know the answer to the question. Remember, as I mentioned before, the markings are the ones that tell you which 2 sides are congruent. So we're going to write that IJ, the segment IJ, is congruent to the segment LK. And the segment IL is congruent to the segment JK. And that is this Understanding Linear Measurements foldable.